Hello, I'm Henry. Welcome back. I just want to talk some more about some of the code in my previous video. I'll have a link in the description, but it talks about emission spectra. And sorry, I bumped the mic there. And analyzing emission spectra. One of the sort of functions that I wrote up was looking to see if some unknown emission spectra is either this pure other element or a combination of elements, or sort of breaking down that unknown. I really glossed over it super quickly, so I just want to do a more in-depth video talking about it because I thought it was a really cool idea that I had. I'm not using any of the built-in functions other than like for loops and stuff like that. I didn't use something fancier than, I don't know, a basic intro class would teach. So I don't know if there's a faster way to do this, but this was sort of the numerical, I guess, way that I figured out how to do it. So let's say I have some unknown of just some random numbers. The reason I have ones and zeros is the way I was reading it in my emission spectra code was that color is in 1 and black is in 0, where I have an image and I can just look at it. It doesn't matter what color it is, but there's color there. So let's say we want to know if I have helium in this. Again, these are sort of just random numbers, but I'll say helium is 0, 1, or 1, 0, 0, 1, 0, 0, something like that, right? So visually, first instinct, it's very easy to see that we have color where we have color. So thus, my unknown should have helium in it. It does not matter that there's a black in my helium where there's a color in the unknown. That just means there's more than just helium in the unknown. So visually, super easy to just compare these two real quick, but I want to write up some code to do it because the lengths of ones and zeros that I'm looking at in my code is 700 long. The image I'm processing is 700 pixels, so I went through each pixel and checked if it was colored or black. So doing 700 unit long arrays that way visually isn't really productive or efficient. So my strategy was to add them, and I'll get to that soon. But this is pretty much just to check if my unknown is pure helium. Or this is a way of checking it. So adding them, I have 0, 1, 2, 0, 0, 2. Now, if my unknown was pure helium, this would be a 0, and this would be a 0, and this would be a 0. And then we would have only 2s and zeros. However, this is a 1 and this is a 0. That means we're up with 1. That's okay. That's not the end of the road for us here. But it does mean our unknown is not pure helium. If I had just 2s and zeros, then my unknown is pure helium, or pure whatever I'm comparing it to. So the next step is I want to take this, my new added number, and I want to compare it to helium. So my helium is 0, 0, 1, 1, 0, 0. And I'm going to write, let's say, C for comparing. I want to compare these two, where anywhere I have a 2 and a 1, I'm going to store that as a 1, because that means I have color in both of them. Anything else, any other combination of numbers, if it's a 1 and a 0, a 0 and a 0, a 1 and a 1, those will turn out as zeros. So only 2, 1 is going to be stored as a 1. So that leaves me with this, right? Now, again, visually, super easy to tell. These are the exact same. These arrays are identical. So that means my unknown does have helium in it, because these arrays are the exact same. Pretty easy to do visually, right, and at this small scale. But again, I wanted to write a function because this is huge. But just to prove that this sort of strategy works, even when it's not included, let's write a new unknown. Let's say our unknown is this, right? And then let's look at hydrogen, some made-up hydrogen, and say it's 0, 1, 0, 1, 0. 1, something like that, right? So I'll do my same strategy. I'll add them. I'm left with 1, 0, 2, 1, 1, 1. Okay, then I want to go and compare them. So I have 1, 1, 1, 2, 0, 1, and I want to compare it to 0, 1, 0, 1, 0, 1. Let's compare those two. And what do I get? I get, remember, 1 on top of 1 is a 0. And then 0, 0, and then I have a 1, a 0, a 0, a 0. These do not line up. So the only place that these, pretty much what this is doing, is checking where these two arrays agree. So up here, we can see that they agree here, and they agree here, and we only care about the color, right? Here, they disagree here and disagree here with color, but agree here. And that's why we see a 1 here. In these other positions, because they don't agree, we see a 0. Because these two arrays are not equal, then we know our unknown doesn't have hydrogen. This, again, don't know if it's the most efficient method, don't know if there is a built-in method in Python, but this was sort of the strategy I used. Please, if you have any comments, concerns, questions, queries, whatever, go ahead and leave a comment. Again, I'll have a link in the description to the video where I talk about the rest of the code I worked on for the analyzing emission spectra. But that's it for this time. Thanks. Bye.